Hello, and welcome to the i4Good Summit webinar series. My name is Andrea Manara from the ITU, the International Telecommunication Union, and I have the privilege of introducing today's webinar. ITU is the United Nations specialized agency for ICTs, and we are also the organizers of the i4Good Global Summit, alongside the X Prize Foundation and in partnership with the 38 UN sister agency. The summit is co-convened with Switzerland. The goal of the summit is to identify practical application of AI to advance the Sustainable Development Goals and scale those applications for global impact. We are pleased today to organize the first session of the workshop on satellite data analysis and machine learning classification with QGIS, in cooperation with the Politecnico di Milano and the UN OpenGIS initiative. We have a distinguished set of speakers today, and they are also assisted by students at your disposal should you have any issues in performing workshop activities. For this, we will be using the Q&A functionality, which you can find at the bottom of your screen. There is also the chat functionality. Please make sure to set the message recipient to all panelists and attendees, and not just to all panelists. You can select this just above the message box. Without further ado, I'd like to introduce our speakers today. Maria Antonia Brovelli, Professor of Geographic Information Systems and Digital Mapping, and the Research Fellow Goritza Bratic from Politecnico di Milano. Before giving the floor to Maria and Goritza, we will run a quick survey. We will appreciate your feedback. Yeah, the survey. We should get. Yes, here it is. The first, to which category does your educational background belongs to? You can select multiple choice, education and training, environmental engineering, environmental sciences, geodesy, geography, geoinformatics, so on and so forth. The second one, what is your current occupation? Again, multiple choice, cartographer, computer scientist, data analyst, geographer, GIS analyst, AI engineer, and so on and so forth. The third one, what is your experience with QGIS? Expert, moderate, experience, basic experience, no experience. And then the last one, what is your experience with remote sensing? Expert, moderate experience, basic experience, no experience. Thank you very much. And Maria and Goritza, over to you.
Thank you very much. And I will start immediately sharing my screen. Okay, I believe that everything is fine. Let me know if it is fine. You can see it well. Can you see my screen?
Yes, it's fine.
Yes.
Okay, so thank you so much and welcome everyone. I want to start before thanking ITU for having organized this workshop. And again, I want to recall that this workshop is organized together and within the UN OpenGIS initiative, which is an initiative led by United Nations, where we want to build an ecosystem, an open ecosystem for UN. Specifically, this workshop refers to one working group of this initiative, the UN OpenGIS. And if you are interested, obviously, you can simply type UN OpenGIS in a searching engine, and you will find immediately the website and all the pieces of information relevant for that. But it is organized within the GeoAI, so geospatial artificial intelligence that we want to focus in this working group. Then you see the title of the workshop, Satellite Data Analysis and Machine Learning Classification with QGIS, but this is only the part 1 of the workshop. We have a second part, and in this first part, we will focus on setting up the environment, so preparing QGIS with all the libraries and the plugins that we need. And then the second item of the day is to preprocess the data. So to prepare the data in such a way that in next lesson, in part 2, we will see how to use machine learning algorithms for processing the data. So today is mainly related to the preprocessing of the data. Then I want also to introduce Gorica again, Gorica Bratic, who is presenting this workshop with me. And she's a PhD candidate and temporary research fellow at Politecnico di Milano. She is working mainly on high resolution global land cover. This is her main project for the PhD, but then she's helping in many other projects. And I have to tell you that you will see she's very, very good. So I'm very happy to have one person like Gorica working with me. But then it's not finished because there are also students of mine helping us, and I want them to show up. Please, if Matilde and Francesco and Juan Pablo and Thomas and Musa, if you can switch on your video in such a way that people can see you and just say hi to everyone, I will be very happy about that.
Hi to everyone.
Hi, everyone.
So thank you so much. And there are students from the Geoinformatics Engineering course of study of Politecnico di Milano. Some people already saw how they are able to manage everything, also the workshop before, and they will answer all your questions. Then at this point, again, before starting, please be sure that you have your QGIS installed, because if not, it's difficult to follow the training. Then that you have downloaded the data. This is very relevant because the data are huge, and therefore don't try to download them now, right now, because if not, this will occupy completely your band. So please don't do that now. Then the other point with respect to the workshop is that Gorica and I will alternate in the workshop. So what we do is that before I will explain you the relevant steps, step by step, and then I give the floor to Gorica, and she will show you directly in QGIS what you have to do. So you will listen at what has to be done twice. The first time with me, simply looking at the slides, and the second time with Gorica doing exactly what I explained before. Okay, let us start with something that is very easy. It's just a very short introduction about QGIS, because we are not entering into the details about that. You are supposed to be able of working with QGIS. So very, very few points about that. What I want to underline is that when you enter QGIS, you find different parts. So the first part here is the bar menu, where you have the main commands, so the main feature. Then there is the toolbar, which is this second part here, where it is possible to activate directly this functionality just by clicking once. Like for instance, if I want to zoom in, I have to click this button. Then there is another part here, which is the panel of the layers. You will see appearing here all the layers that you are using. And specifically, if you want to visualize them, you have just to click on them. If you don't want to visualize, it is simply of unclicking them. The other general rule is that when you have many layers, the layer that appear in the forward of your screen is the first layer here. On the opposite, the last layer won't appear if you have other layers before it. Then the other window here is the map panel, where your map appears. The last part to take into account is this status bar, where you have the main pieces of information about the coordinates, the scale, the coordinate reference system, and so on. Those are not all the possible panels or toolbars that you can activate. As a matter of fact, there are also others. We won't do that now. But if you want to activate other panels or toolbars, you go here in the main menu, select view. There is the list of possibilities appearing here. So if you select panel, you see appearing this window, and you can select, for instance, layers or the other you want. If you want to add toolbars, you can go here and you will see the list appearing, and you can decide which toolbars you want to activate, to have visible. Another option, instead of doing that, is to simply right click with your mouse in one point here where there are not icons. And then there is this window appearing with panels and toolbars. It's exactly the same. You can select either here or here the panels and toolbars that you want. Okay, this is a very short introduction about QGIS, but you see that it's very similar to also to other GIS. Let's say something about the plugins, because QGIS has some core models, but then there is the possibility also of using many other functionalities that are provided by people generally. So everyone can contribute, as a matter of fact, because it is an open source. So everyone can contribute with new plugins. With respect to plugins, in order to install the plugins, and we will see that we will be using free plugins, you have to go to the main menu. There is plugins, that is enough obvious. And what we want to do is to manage and install plugins. Perfect. So this window is appearing now. And if we select all the plugins, here we will have the long list of all available plugins. The plugins we will be using are the semi-automatic classification plugins, the quick map service plugins, and dzetsaka plugin. So in the first case, we will start with simply typing semi-automatic. And in this case, the plugins is put here, so in evidence. And what we have to do is to install plugin, because we want to install the plugin. So you see, it is very easy and it is very logical. This semi-automatic classification plugin is the one that we will use today for downloading the data, for preprocessing the data and also for doing some simple algebraic operations with the bands. The second plugin we will be using, not today, but next day, but we will install all the plugins today because as I said, we want to prepare the environment. The second one is Quick Map Service. Also in this case, it's enough to write Quick Map Services and then at this point to select it. And again, to use install. This plugin is specifically for providing backgrounds to our data in such a way that we can contextualize the data. And then we will use this plugin next time for collecting, training, and testing data for using then the machine learning algorithm. The last plugin that we will use is dzetsaka. Again, we will type here dzetsaka and it appears here. We will select it and we will install it because this is what we want to do, to install it. Fantastic. This is a plugin helping us in applying machine learning classification tools. And specifically, we will use next time the Gaussian Mixture Model, the random forest, and the key nearest neighbors. Those are the three algorithms that we will use next time. Okay, and now it is up to you. So I leave the floor to Goritza, and she will show you again what to do in QGIS.
Okay. Hello, everyone. Thank you, Professor Brovelli, for wonderful introduction, and thank you, everyone, for joining the workshop. I'm starting sharing my screen, and I hope all of you can see it by now.
Yes.
Okay, thank you. So I already opened the QGIS, not to waste time, but I will just quickly show and also to highlight this fact. To run QGIS, this is only for Windows, QGIS with GRASS. On Linux and on Mac, it will be only one version, but on desktop there is one with GRASS and one without. So we want to use the one with GRASS. That's for now. Another point, Professor already told you about menus, about toolbars, and basically what you see in the menus, you see also in the toolbars, and it's when you become familiar with QGIS, you will use the toolbox and the tools because it's just single click to access one functionality. But today I will use menus, because for you it's easier to follow, like I open the menu, then I select some functionality instead of me just clicking and opening functionality, and maybe you will not be able to understand what exactly I did. So this is a bit maybe a longer path, but it's also more secure for you to understand how it's done. Okay, so we will start with installing plugins. So as we said, we go to the plugins menu. I will reduce a bit the size of my windows because I cannot see all the functions due to the zoom features. Okay, sorry, just a second to organize myself. I think it should be fine like this. Okay, so we go to plugins menu. And then we select this first option, manage and install plugins. So it's enough to click once on it, and we will get this type of windows. You will not see exactly what I see. This depends which kind of plugins you have installed, but let us work together to, at the end, to have the 3 plugins that we need. So for now, let's switch to this tab, all. And what we need to do now is to simply, in this search box, is to simply type the name of the plugin. So the first plugin that we need is semi-automatic. It's even like if you type part of the name, it's enough. Usually you will already get it listed here. So this is the first plugin that we need. In my case, it's already installed, but I can, for example, uninstall it quickly now and show you that, okay, so now I install it. I want to highlight here, if you used before semi-automatic classification plugin and you didn't upgrade it to the latest version, please do it now, because the latest version has some functionalities that are very useful for our workshop. So please, if you have an outdated version of this semi-automatic classification plugin, update it now, please. Okay. Then we repeat the same for the other two plugins. One was Quick Map Services. So we just type again in the search box Quick Map Services. We select it in the list and we click on install, or I will not repeat again, but if you didn't install it before, you will see here install plugin. And the last plugin is dzetsaka. It's dzetsaka. But also if you type classification tool, because this is also within its name, you will get this if you didn't understand exactly what is the... Okay, so again, we find it, we select it, and we install it. Okay, so if you were able to follow me, I think now we have all the necessary plugins ready. So back to you, Professor. You are muted.
Thank you, Goisa. And let's go ahead now. So again, now we are able of installing our plugin. Let's go ahead and see what we want to do now. So what we want to do is to manage satellite imagery. Also about that, very, very few points specifically related to Sentinel-2, which is the Sentinel WOS image we want to pre-process today. So first of all, I don't spend time speaking about what remote sensing is. You are supposed to have at least the basis about that. I want just to tell you that we have sensors on the satellites, and those sensors are capturing the electromagnetic wave which is reflected by the Earth's surface, not only by the Earth and the atmosphere, to be more precise. And we can have different sensors sensing in different parts of the electromagnetic spectrum. And this means that this is what we call the bands. So there are different bands corresponding to different portions of the electromagnetic spectrum that can be sensed. Specifically, if you look at this image, you see here that we have a band 2, which is in the visible part, a band 3, which is in the visible part, band 4, which is again the visible part. And then we have another band here, which is the band 8, which on the opposite is in the near infrared. So it is something that we can't see with our eyes. Only this part can be seen directly by us. Okay, so with respect to Sentinel-2, we have many possible bands, and specifically 13 different bands. You see them listed here. corresponding to different wavelengths, obviously, and corresponding also to different spatial resolutions. So the resolution on the ground. We have bands at 10 meters resolution, 20 meters resolution, and 60 meters resolution. And you see here the detail about them. The other relevant point is that besides the spatial resolution, they have also a temporal resolution. So their revisiting time can be different with respect to different satellites. With respect, if we are speaking of Sentinel-2, the revisiting time is of 5 days at the equatorial line. So it means also more frequent in the other latitude. So what we have is with these satellites, the availability of imagery, in this case, every 5 days, with such a kind of resolution. The best one is 10 meters resolution. Okay. Now that we have at least a rough idea about what we want to preprocess and process, let us see what we need in order to start all the procedure. First of all, we need to know where we want to clip the satellite images. The satellite images is very big. So which is the portion of the Earth that we are interested in? This data will be provided as a vector data, and specifically we decided to consider one bounding box corresponding to this region around this village, Al-Hashimiyya village, which is in the north of Jordan. There is no reason why we decided that. It's just by chance. We decided to propose this example. The area we are considering is described by a bounding box whose name is working_area.shp, so shapefile. Obviously, this is also something that we decided you can give your the region the name that you want. This is a vector file. For importing this vector file into QGIS, we have to add a layer, which is a vector layer. So we go to the main menu. There is this layer. We select a layer, and you see there is this long list of possible functionalities. But now we are interested in adding the layer. So we select add layer, and then at this point we can also select which is the typology of the layer we are interested in. But I told you that this is a vector layer. So what we want to do is to add a vector layer. Fantastic and very easy. At this point, this window is appearing, and in this window, the only thing that we have to change, as a matter of fact, is to go here and write or select in this way. So in browse in the folder where we have the data, and select the specific file. Once you have done this, you click on add, and then you can close this window because we don't need anymore this window. So this is exactly what we have in if we are using QGIS 3.10, which is the release that we suggested many months ago when the workshop was proposed. Meanwhile, and at that time, 3.10 was the long-term release of QGIS. So we decided not to change that because we were thinking that some people could have already installed the QGIS. But meanwhile, something changed, and specifically there is a new release now that is the long-term release, that is the 3.16. If you are using the 3.16 instead of the 3.10, there are very few things changing. Specifically, in this case, it is exactly like before, but you see that here we have some more options. We are not interested in this option. So for us, nothing is changing because this is the case, as you see, of 3.10. And this is the case of 3.16. So exactly like what we did before, you browse and you find the working area shapefile, then you add, you close. That is what you need to do. So nothing different. Fantastic. Now that we have our vector file, we want to give it a specific style. So we want specifically to have simply transparent. It is a polygon. We want it to be transparent inside and with a red border outside. Okay, what we do for doing that? Right click on the, now we have the file also here in the list of the layers. So right click with the mouse on working area, the name of the file. We have this menu appearing, selecting properties. And at this point, there is this panel appearing. And what we want to do, we want to change the symbology. Okay, so we select the symbology. Once selected symbology, specifically, we see that there is already the symbology we are interested here, which is the outline red. So click on that and click on OK. And that's that. Now we have our wonderful bounding box for the area we are interested in. This is what is appearing on your QGIS. In order to be sure that we are in the right place, but this is something that we don't ask you to do today. I only show you that this is correct, so the bounding box is correct. And therefore, if I put a background behind the bounding box, you see the bounding box is transparent, so our working area is transparent, and we can see also what is in the other layer, that is the second one. And you see that it is Al-Hashemiyah village. So it is correct because you see here Al-Hashemiyah. And if we want to better understand what is this place, we can also upload Bing satellite image. We will see next time how to do that. And you see here that it is a village in the middle of the desert. So this is the area we are considering, and the bounding box is correct. Wonderful. So up to you, Goritza.
Thank you. So back to QGIS. So we will go straight to first load the vector and then to apply the style that Professor showed us. So to load the vector, there is many ways. So probably if you are using QGIS by now, you already have your favorite approach for doing this. But I selected one of them just to keep it simple. So we go to layers menu, add layer, and then add vector layer. We click on add vector layer, and we get this window, data source manager for vectors. And now here we can either copy the path to the folder with the data, or we can search for the folder with the data by clicking on this button, browse. So this button with 3 dots, we click on it, and we find you find the folder in which you downloaded the data that we provided you. So for me, it's here. I found my folder. Now I have to select exactly, there will be more files, working area dot, and then extension will be different. We need specifically the one with .shp. So we select working area .shp and we click on open. And you will see here now the full path to this specific file is written. And when that's ready, we just need to click on add. And it's already displayed in the list of layers. And so we can also close these windows because at this moment we are not going to add any more vectors, so we just close. I will just remove also this map, so we will not use it, and also it's not relevant. It was just for showing how the map looks like. And I will zoom to my area. So now you see that it's a rectangular polygon with the green fill, and we want to change it to be just transparent with red borders. So to change the visualization, we go to the layers and right click on this working area vector. So right click and then properties. We select properties and we have to switch to symbology tab here. If it's not by default when you open, you just select symbology. And we have here different predefined symbols that we can use, and we will just search. I can tell you that there is the one that we are looking for here. So we just scroll a bit, and when we find it, it's this one called outline red. When we find it, we select it, and we click either on apply or OK to apply this style. So again, on symbology tab, we search for this specific outline red symbol, and then we click OK. And now we see this red box. And if I'm not wrong, it's again your turn, Professor.
Yes. Yes, thank you. So let's go ahead. Meanwhile, giving you some time if you are a bit late and you have to finish your task. Okay, so what we want to do now we want to start working with the imagery. So we want to start using the plugin for the classification. And specifically, in the beginning, what we will be doing is to download the images and selecting what we are interested in. Okay, so for doing that, as we installed the semi-automatic classification plugin, now we can see in our main menu that we have one more functionality with respect to the initial ones, which is SCP, so semi-classification plugin. For using these plugin, there are more possibilities. So it can be assessed in many ways. One possibility is to use directly from here, from the menu, the semi-automatic classification plugin. But as a matter of fact, we have also a working toolbar appearing here related to the semi-automatic classification plugin. And we can have also this doc panel. So the semi-classification automatic plugin can be assessed through all these possible tools. What is helping us in working directly with the plugin is that this window is appearing, which is the specific window of the semi-automatic classification plugin. You see that this is another window, is not the main window of QGIS, and in fact it can be minimized or maximized, or it can be closed as well. Okay, so we will see how to work with these first of all, this one, so the main one in the main menu, and this semi-automatic classification plugin. What we want to do is to assess the Sentinel-2 data. And for doing that, so the Sentinel-2 data are accessible in many ways. This is not the only possibility. Also because through this Copernicus Open Access Hub, the data are made available by means of API. So the plugin that we are considering is a software that is able of connecting to this API for downloading the data we are interested in. Some months ago, it was possible to access through QGIS, this Copernicus Open Hub Access, only if before you had the credentials, so the login and the password for entering the Copernicus Open Access Hub. Nowadays, it's no more necessary. So now you can choose if using your credentials or not using your credentials, and we will see how. So let us start seeing how it is possible to download the image. We said that we have to go here, then in the main menu, and the list of possible functionalities appear. What we want to do now is to download products. So we will choose download products. Fantastic. Now we obtain this window of the plugin, and we see that we have 3 tabs: the login data, search, and then the download options. We want to start with this login data. And if you enter into this login data panel, you see that there is the possibility of downloading Sentinel's data, but we have much more possibilities because the same plugin helps you in downloading also Landsat data or in downloading Aster and MODIS data. For them, you have to enter your user and your specific password, and there are instructions about that. If you look at the manual of the semi-plugin, of the semi-automatic classification plugin, but we want to concentrate today on the Sentinel-2 data. So we will put here our user and password, or in alternative, we will flag this use alternative search for Sentinel-2, and in this case, no authentication is required. Therefore, if you don't have the user and password needed here, don't worry, because now it's definitely simpler. You can simply flag the use alternative search for Sentinel-2. Okay, wonderful. Let's do in this way. And now we can connect to the server of ESA providing the data for us. Okay, So what we want to do now is to search for the specific data we are interested in. Okay, so let's go to the second tab and let us search the data. Which are the parameters we are interested? We already saw which is the bounding box of the area we are interested in, which is described by the working underscore area shapefile. We know which are the products we are interested in. We are interested in the Sentinel-2 products. And then we decided to propose you to search for Sentinel-2 data between the 17th of October 2020 and the 20th October 2020. The last parameter that can be chosen is the maximum cloud cover. And in this case, we will leave 100%. Obviously, you can reduce, and generally it is better to reduce the max cloud cover because reducing means that you have better images. But as this is simply an example, let us consider 100% also because we saw that these images have a very few clouds. But again, when you want to have an image that is better, please consider reducing this number. Okay, so now we have to insert all these pieces of information. Let us start by inserting which is the area of interest. So you see that here in the window, search parameters, we have, first of all, these two parameters that are the upper left and the lower right. So in principle, we can also type here the coordinates, but obviously this is not so comfortable. So luckily there is one other possibility that is this one. So go here where there is show and click on plus and activate show. So with show activated, click plus. At this point, we can minimize this window because I told you that this window can be minimized. And let us see what we see behind this window. Behind this window, we have the principal window of QGIS. Fantastic. And we have our rectangle corresponding to the bounding box of the region we are interested in. At this point, what we do is to left click close to this point, and then with the mouse, so left click with the mouse and right click with the mouse close to this other point. And we will see that there is this rectangle, this pink rectangle appearing. Obviously, if we realize that we want to change something, we can again left click in another point here and the rectangle will enlarge, and right click with the here, and we will see that rectangle will change. You don't need to be precise with respect to this pink rectangle, because as a matter of fact, we are interested in this region. So one good point can be to be sure to have all the region with us, to consider a rectangle that is a bit larger with respect to the bounding box we are considering, in such a way to be sure to have all the data that are of interest of us. Okay, so in this, now we have selected the region. So maximize again the or unminimize or maximize again the panel of the semi-automatic classification plugin. And in doing that, you see that here the coordinates of the region of interest are directly appearing. So those are the coordinates of the pink rectangle that we created before. Okay, so now that the location has been selected, we can select the product, and we are interested in Sentinel-2. We can select the date from to, and we can select the maximum cloud. Here, simply typing or selecting from the calendar or selecting from the list. Okay, then at this point, after having completely selected all the parameters we are interested in, we click on Find. So you see here an icon with written Find, and what we want to do is to find the images with the characteristics that we inserted. So click on Find, and there is the list of the images corresponding to our parameters here. So we see this list of images. Okay, so at this point, having all these images, we want to select one of them, which will be the image with we will be working. In this case, we have decided to propose you to work with this image, which is the first one appearing here. L1C and T37 SBR and so on and so on. Okay, wonderful. If we want, it is possible to see the preview of the different images, and the preview is possible simply clicking on this icon. So we can have a look at the images, and then we decide to choose this image. So at this point, if we want to use this image, it means that we want to remove the other images because we are not interested in downloading them. Wonderful. So as we are not interested in downloading them, what we can do is to select every single image and right-clicking with the mouse in deleting. Or another possibility is to select all of them by keeping hold the control and then select the selection. In this case, we are selecting the other images and then using this minus tab, we delete the images. We have no more available there. Okay. Before going ahead, I want to just to discuss with you an important point, because as you saw, the image we are selecting is an image 1C, L1C. So L1C means that it is an image not corrected with respect to the atmospheric reflectance. What is the reason why we selected this image and why we suggest you not to use in general these kind of images? The L1C is the first level product, as a matter of fact. Besides, after the raw image, is the first level product. And as said, it is not corrected with respect to the atmospheric reflectance. So the point is that in your image, you don't see only the reflectance of the ground, of the surface of the Earth, but also the effect of the atmosphere. And this can cause problems in the interpreting of the image. So it is generally better, and it is warmly suggested, every time you have the possibility of choosing between the 1C and the 2A image, of, it is definitely better of using the 2A image. But the 2A image are available over Europe since March 2018. And they are available in general, globally, worldwide, since December 2018. So it means that if you want to use an image that is older than that time, it is possible that you don't find, if you are outside Europe, the correspondent 2A image. And you have available only the 1C. So at this point, there are many possibilities. One possibility is that you learn how to use SNAP, where SNAP is a tool provided by the European Space Agency, allowing you to process the image, pre-process and process the images, and also of correcting them with respect to these atmospheric reflectors. So it's one of the functionalities made available by SNAP. But in our case, we wanted to show you what is possible to do simply using QGIS. I want just to underline that this is not the best way of doing. The best way is every time I have 2A available, I use the 2A image. If I'm able of using SNAP, I will correct my image, my 1C image with SNAP, obtain the 2A image with SNAP. If I have only the 1C level product and I'm not familiar with SNAP, I have this possibility in any case with QGIS. Okay, so what we decided to select the level 1C in order to show you what you have to do in this worst case where you need to work with the 1C level image and you have familiarity only with QGIS. Okay, so at this point, after this long description, and please again remember to use the 2A, what we will do now is to download the data. Before downloading, we need to unflag these only if previewing layers. So we need to unflag preprocessed images because we will do later. And we need to flag load bands in QGIS. And then that's that. At this point, we can run the command. But this will require time, so don't run it now. We already provided to you also the downloaded images, so you don't need again to occupy your band now with this data. Okay, and the last point is that now we have downloaded the data. They are raster data. If we want to add them into QGIS, we will do layer, add raster layer because it is a raster layer. We will go, oh, no, sorry, stop here, no. Let's stop here, and I believe that probably is also time of having 10 minutes of break.
Professor, I suggest that we see this step.
Okay.
Can you hear me?
Okay.
I suggest that we see this step so that they can have some time to repeat this during the break.
Perfect. Let's do in this way. So again over to you guys in such a way that you show it, and then we go ahead.
Okay, and also I want to say that there are some people who were not able to download the data. So for them, for those who downloaded the data, we don't recommend to run the command and download because it's the same data. But for those who didn't download the data we provided, you have nothing to lose if you run the command now. So it's better if you do it. So once more, if you downloaded the data that we provided, don't run the command. If you didn't, then run the command. I hope it's clear. Okay, now I'm going to show the how to download this specific image. So again, we are going to use the menu, and this time the menu is SCP. So we click on SCP menu. If you correctly install the plugin, you should see SCP here. So SCP, and then download products. When we click on download products, sorry, okay. First, we will see this, but we first have to go to the login data tab to either insert credentials. So I'm switching to login data tab. And
sorry, Goritza, I think you're not sharing your screen.
I am. Professor, do you see my screen? Yes.
Yes, I see your screen.
Okay, sorry, it's my fault. Sorry.
Okay. No, if I didn't share, it would be good to know, but okay. Luckily, this time this is not the case. So as I was saying, first when we open download image, we will be in the search tab, but we have to switch to login data. And then if you have credentials for Copernicus Hub, you insert them here. Otherwise, you check this box to use alternative search for Sentinel-2, where you don't need any credentials, so you can remove them. And if you don't have credentials here and you didn't check this box, you will not be able to download the data. I saw that there were many questions in the chat. So when you are not able to download the data, first thing is check your credentials. So if you put the credentials, check if they are correct. And then if they are not correct, or the easiest way is just to check this box, use alternative search, and the problem is solved. Okay, so now we can go back to the search tab and define our parameters for the image that we want to find. So we switch to search. And here we have first to define upper left and lower right coordinates. We saw before that we have an easy way to do that, but again, we can just type in the coordinates that we need. But let us see the easier way, because that's the whole point of this workshop, to learn some tricks. And okay, so we click on this plus button, and then we minimize the window of the semi-automatic classification plugin. So we minimize it. And more or less now we have to do left click, but pay attention, left click in the upper left corner of our working area. And then right click on the lower right corner. And you will see this semi-transparent red box. So again, left click on the upper left corner and right click on the lower right corner. So you should then get this semi-transparent rectangle. Again, it has to be approximately the size of the working area. So our initial red box, it has to be approximately this size, but it doesn't have to be precise, because in any case, satellite images are big, and we are just selecting some portion of it. So we don't have to be, the bottom line is we don't have to be so precise here. Okay, and now we can go back to semi-automatic classification plugin. So we just unminimize or maximize from the how is it called, the start start menu, I guess. I'm sorry that I don't know the name for this. Okay, so when we are back, we should see now upper left and lower right coordinates filled. We are left now with defining the products, and by default it will be Sentinel-2, and if it's not, again, we select Sentinel-2 here because this is what we are aiming at. Then we can, we have to define the date, which should be from 17 October 2020 to 20 October 2020. We can use the calendar for this, but I prefer to type this. So you use whichever way you prefer. So I will just type 2020, 10, 17 in the first box, date from, then 2, 2020, 10, 20. Okay. And then maximum cloud cover, we will remain 100%. And with this, we can, we defined all the necessary parameters, and we can click on Find button so that we obtain all the images with the parameters that we defined. So find, and here is the result. So we have 8 images with these parameters, more or less in this bounding box that we selected. And we are going to use only one of them. Yes, only one of them, which is the one that we are going to use is listed under 4. So if you, or let me say it's T37 SBR. I think this is unique enough. No, L1C T37 SBR. So maybe if you didn't exactly specify all the parameters the same, you might have a bit longer list. So it's useful to know identification for this specific tile. So this is the tile that we are going to use, but what we want to do now is actually to remove those that we are not going to use. So to do so, then we will remain only with this one, and we will download this one, or okay. So to select all the other bands except this one, we can use, we can, for example, click on the first one, and then hold Control, and then keep selecting the other ones. And for some reason, they are not selected. Okay, okay. There is a bit of lagging for some reason with selection, but you will know that the image is selected when this number is in bold. So you see that now with some lag, I don't know why this happens, but there is some lag when I click on image, it's not immediately selected. But at the end, I have all the images selected except the 4th one, and you can say that it's selected because it's in bold. Okay, so now when we selected them, we click on this minus and we remove them. And we are left only with this image here. And at this point, we just have to uncheck these buttons here, because we don't want to pre-process images now, because we will do it later in a single step, so that we also explain what we are exactly doing with the processing. And then also this only if previewed in layer, this is if you preview the, yes, if you downloaded the preview of image, but it's really not mandatory. So we just uncheck this box and this box, and we are ready for downloading. Again, if you already downloaded the data that we provided, there is no need to run this command. You have this data ready. Okay.
Okay.
And I believe it's time for a break now.
Yes, thank you so much, guys. I want also to very quickly answer two questions that I saw. First of all, why is the maximum cloud cover set to 100%. As I said, you can choose what you want. So we simply left as it is, but generally because we know that in this R&D's time there were not clouds, as a matter of fact.
Yes, and also if I can add, like we kept this we didn't filter with this 100%. We didn't filter by the cloud coverage, but at the end we selected image that for which cloud cover is very low. So
yeah, okay. And these answer the first question, but you can obviously select with a smaller cloud coverage, and I suggest doing that, obviously. And then the other question was that there are some people who are not able to connect, to have the images listed. This is a problem of connection, as a matter of fact. It's a problem of connection because in this case we are connecting to the images on the server of ESA. So it requests time depending on your band. And you are already using the band for this webinar. So for sure it will be faster when you are not in the webinar.
Yes, and it can be also due to if you tried to get the credentials for Copernicus Open Access Hub, it might the credentials might be the reason why you are not able to download the data. So I strongly suggest to use this option of alternative search because I think it's more convenient now.
Okay, thank you. I believe that now it's time for the 10 minutes break. So see you. Thank you so much and see you in 10 minutes. Okay, welcome back again. Let us start with the second part now. Let me share the screen with you. And okay, go to presentation mode. Wonderful. So now, I don't know if you downloaded the image. If you didn't, that is perfectly correct, because you have already the image in the zip file that we provided you. What we want to do now is to start working with this image that we have chosen before. Okay, so this is a raster image, this is a raster data. So what we want to do now, if we don't have it in our QGIS, but it is in the folder, is to add this image, so this raster, to our QGIS project. For doing that, as it is a raster, we go to Layer, Add Layer, and what we want to add in this case is a raster layer. Before we choose the vector, but now we are considering a raster layer. Okay, so this panel appears, and what we have to do, exactly like we did before, is to select the raster dataset we are interested. So, or we type the name, but it is not so comfortable, or on the opposite, we go here, we browse in the folder where the file is, and we select all the JP2 files corresponding to the data we are interested in, which is this one. Okay, once you have done that, we add the layer to our project, and then we can close the window because it is no more needed. And at this point, we see appearing, first of all, here in the panel of the layers, we will see also these layers corresponding to our image, along with the working area that we already added before. And we see here the image and the area we are interested in. By now, the raster appears as a gray tone raster. We will see later what to do. Okay, so at this point, if we go to the folder where we have our data, or if we downloaded them, we will see that we have the 13 bands of Sentinel-2. Then we have one more file, which is a GML file containing the cloud, the mask for the cloud. And we have two more files that are the metadata associated with the image we are considering. Okay, so let us see how to do if we want to preprocess the image, because now we have the image into our QGIS project. What we want to do is to preprocess the image, and we want to use the SCP. So again, select SCP. Before we selected download products because we wanted to download, but now we want to preprocess them. So select preprocessing, and there is the list of the possible satellites, imagery we want to preprocess, and we are interested in Sentinel-2. So we select Sentinel-2. Okay, what we want to do now, I recall you that we are using one special kind of image, which is the level 1C image, which is not corrected with respect to the atmospheric reflectance. In this case, and only in this case, because if we add the 2A image, this is not needed. in order to preprocess it, eliminating the effect of the atmosphere, we will select this apply DOS1 atmospheric correction. That is one specific correction. But we want to apply it to what? So first of all, here you have to put where is our image. And then you have to put here in the point 2, the metadata related to the image. Okay, so at this point, once you have put the directory containing the bands, so our image and the metadata we are interested in, and applied flagged the apply DOS1 atmospheric correction, we go ahead and we decide which are the bands that we want to use. So where we want to apply this correction and then use them for going ahead with our exercise. We decided not to use the band 1, 9, and 10. Why? Because these bands are bands at resolution of 60 meters. So we keep only the bands corresponding to 10 and 20 meters because they have a better resolution on the ground, spatial resolution on the ground. Now, for unselecting these is, as we saw before, you can select and then remove with minus, or you can, using the control and clicking on them, select the 3 of them at the same time, and then using the minus and removing them. Okay, once you have made all these choices, you can run the command. It means that those only the selected, so not the bands at 60 meters, will be corrected with respect to the atmospheric correction. This is a command taking time, so again, we ask you not to run it now because we already provided the corrected images. Okay, so let's go ahead. At this point, we want to visualize the data that we provided you in the folder. Okay, so what we have to do, these data are raster data. So again, as before, what we have to do is to go to layer, add a layer, and add the raster layer. We will go to the folder where these data are, select the TIFF file, add, and close. In this case, this preprocessed image have the same name as before, but before it, you will see that there is this RT. So RT means that they are the bands already corrected with respect to the atmospheric effect. Okay. So you can see again now the data that we are providing you as already corrected. We can see the image, but it is not completely clear because again, they are gray tone raster. So you see how they appear here, but we will see later how to do for a better visualization of the data. Okay. Okay, so at this point, what we can do is to remove the images that we imported before because they are no more needed. So the raster data corresponding simply to L1C that we used before can be removed. How it is possible to remove them? Again, control and click of them, remove layer. And this window appear asking you if you want really to remove them, and you will click on OK in such a way that we remove the data that we downloaded before, because we will be working with the RT data now, which are the ones corrected. Okay, so now it's your turn, Goritza. And what I want to remember to all of you, simply not to run the preprocessing because it takes time. Up to you, Goritza.
Okay. So we should first start from opening original image, so the one that we provided to you and you downloaded. And that is done from, again, it's similar to opening a vector. So again, we go to the layer menu. We go to add layer, and this time we go to add raster layer. So layer, add raster layer. Okay. We get a data source manager for rasters, and as before, we now search with this button with 3 dots. We are searching for the folder where our data are saved. So I click on 3 dots, and we are going to use the folder that is L1C, T37, SBR, etc. Not to read all the characters, I will just expand this a bit so that you can see what is there, but it's, let us say that this is we are going to use the folder with the longest name out of the folders that we provided. So we select that one, we open it, and you will see many JP2 files, and we exactly need these files. So let us select all of them. You can also use Control to select all of them, or other shortcuts. I simply kind of drew the rectangle and selected them. And then we click Open and Add. And now I can see all of these different bands of an image displayed here, and I can close the data source manager. I will close also now the SCP doc because we will not use it, but maybe for you sometimes in future it will be useful. Today for this workshop it is not, so I'm going to close it so that we can see better the list of our images. And another point is now we don't see anymore the bounding box, the working area that we had before, because it's at the bottom of the list. So what I'm going to do is I'm going to select it and drag it at the top. I have to do it like this. So when we drag it to the top, then again we will see our working area. Okay. And now that we have original images, we can start with preprocessing. We are going to use now SCP menu. SCP menu, preprocessing, and Sentinel 2. So SCP preprocessing Sentinel 2, we click, and we get this window. We have to select again the directory with Sentinel-2 band. So this is the same directory that we use to load this file, these layers here. So we click on this icon of a folder to find our folder. We go to the folder and we select again the one with the longest name. We click on select folder. And we will see all the bands that are available in this folder here, but we also need to select metadata file. So it's this field here. So we click on this button with, again, folder and the file in it, open a file. And for metadata, we are selecting the MTD MSIL 1C XML document. So the one with the longer name between the two XML documents. We select it and we open. And okay, that part is ready. Now we need to select apply DOS1 atmospheric correction. And we are going to uncheck create band set and create band set tools, because these we will do in a separate step later. And finally, we have some bands that have lower resolution. So they have 60-meter resolution, which is lower than all the other bands, 20 meters or better. So we are going to remove these bands. These bands are band 1, band 9, and band 10. So we can select one by one and click on this minus to remove them. And I know I suggested you to hold Control and select these bands and then click on minus, but I realized for some reason this doesn't work so well. So since it's only 3 bands, we can do one by one to avoid mistakes. So I select band number 1, I click on minus. Then I select band number 9. You see, band number is written at the end of the file name, so pay attention that it's, don't look at these numbers at the beginning. So we look here to see the band number. So band 9, again minus. And finally band 10, minus. Okay. So this is it for the pre-processing. Now we can run, but I'm not going to do that because I have this ready and it takes quite some time depending on the power of your machine. Not the power, but yeah, the RAM. And so we are not going to run this now. Instead, I'm going to close this and open the images that we pre-processed before, and we also provided them to you in the zip file. So the procedure is the same as for loading the original image. So we are going to the layer menu, add layer, add raster layer. And again, I navigate to the folder where my data is by clicking on these 3 dots. Sorry, now it's very small, this. Okay. I click on these 3 dots. I go to the folder that I provided to you, and I have it too. So in this case, we are going for RT folder. So we should use this one. This RT folder contains pre-processed bands. So we select that one and we click on open. And we select all the images available in this folder because these are all images that we need. So we just select all of them. So Control A or select like dragging on top of them. We click on open again. And finally, we click on add here. And I see already some RT images in the layers panel, so I can close this. This means that I successfully added these images. Now, since we have pre-processed images, we don't need anymore the original image, so we can remove it from QGIS. And currently, it's not very convenient because some bands are at the top, then we have pre-processed images in the middle, and some bands are at the end, but still we can remove. So first, I will select the original image that is the 3 bands that are on top of preprocessed images. So just to like make it clear, we need to remove all the layers that whose name is starting with L1C, and we keep those that are starting with RT. So I select the first 3 that I see here, holding shift, clicking first, clicking last, holding shift, and right click, remove layer. So I select those that I want to remove. I right click on them and remove. So now I removed the first 3 and I will scroll down to remove the rest with L1C. So again, I click on first, hold shift, click on last, and right click, remove. And I confirm removal. So now we are left only with the pre-processed image. I don't know if that's all before the next step.
Yes, I believe yes. So let's go ahead with the next part, sharing the screen again. We are here. So now we have the 10 rasters corresponding to the 10 bands that were preprocessed before. The name is RT behind all of them. And we removed the some bands because they have a resolution of 60 meters. So as we wanted to do a fine classification, we decided to keep only the bands corresponding to 10 and 20 meters. What we will do in the next step is to put all the bands together because now they are separate. So we want to create what is called the band set. Let's see how to do that. Again, we will use the SCP. And if you go to SCP, you see that the first functionality is band set. That is exactly creating the set of our bands. So select SCP, select the band set. Now, at this point, if we refresh here, so this is the window appearing, and if we refresh here, we will see the different layers that are available, and we can select them in order to select all the bands. Okay. Then at this point, we will press this add band to band set in such a way to create all to merge all the selected bands into the band set. Please pay attention to this fact that when we see here the list of the band, in order to put them in the correct order, we have 2 possibilities. One possibility is to use this wavelength quick setting. So we select here the Sentinel 2 in such a way that they are put in the correct order with respect to the wavelength. Or another possibility is to go here and by using the arrow, put them again in the correct order, starting from the smaller center wavelength, going to the larger one. Specifically pay attention to the band 8, because you see that we have a band 8 that is slightly different with respect to band 8A. So band 8 has to be before band 8A, okay? Or the other possibility is simply to use this one, that's that. Okay, so at this point, what we want to do is to create a virtual raster of the band set. So we have to flag this option, and then we can run the command. Okay, what is this virtual raster band? Virtual raster band, as a matter of fact, is simply a text file that is pointing to the multiple raster dataset. So we are not really creating one new raster. We are simply creating this text file. So this is the reason why it is also very quick to do this operation, because we are creating a text file that is simply pointing to the different rasters that we saw before, putting them in the correct order with respect to what QGIS is expecting then. Okay, so we run and we create this new file, which is the type of this file is VRT, the virtual raster format. Okay. Then at this point, we have this new raster. We have if we want to visualize the new raster, virtual raster file that we created, we have to click on it, go to properties, and once we go to property, we can first of all verify the characteristics of this file. So we have this characteristic here, and then we have to pay attention to one point now, because before we had 14 bands. We started with 14 bands. Then we remove 3 bands, and therefore our new raster has only 10 bands. And you see that the number has changed. So we have to pay attention to this fact that now in the new enumeration that we have, as we removed the 3 bands, you see that band 1 is the blue, band 2 is the green, band 3 is the red, and so on and so on. You see that the number of them has changed. And we have to pay attention to that when then we want to visualize them in a correct way. So just keep in mind this point, and we will go back again to the visualization, because if you see here, this visualization is for sure not so good visualization. We can't understand what is really this image, what is showing us. Okay, before doing that, let's do another thing, that is clipping our image in the area of interest of us, because the image is larger than the area of interest of us. So it is useless to keep a so big image, because we are not interested in what's happening outside the area of interest. So let us clip it. Let us see how it is possible to clip it. The data we have now are in a raster format, and therefore, in order to manage this data, we go here and we select in the main menu raster. What we want to do is to extract from the image only the portion corresponding to the area of interest of us. Therefore, what we want to do is to clip the raster. There are many ways of clipping the raster, taking into account many different elements, but what we want to do is to clip our raster in our working area. Okay, so when we select extraction, clip raster by extent, we see that this is appearing. So we have different possibilities. The possibility we want to choose is to clip using one layer extent. and specifically our working area. And therefore we can select here, use layer extent. We want to select the data in the working area, and then we will click on OK. And at this point, we know where to clip the data. But we have to add here, which is the input layer. So which is the layer we want to clip? The input layer is the virtual raster file that we created before. So here we put the input layer, the virtual raster that we created before. We clip it using the layer extent, and the extension that we will be using is the working area. Clicking OK. The last point that we have to add is the name of the new layer. So we are clipping the data and we want to give this clipped file a new name, and we will call it clip.tiff. So it will be a TIFF file and its name will be clip. Once we have defined the input layer, the output layer, and how to clip it, we have done everything, and therefore we can run it for obtaining the new data set. Okay, so now we have the clip file, and by now you can see something like this if you select the clip file, which is not so clear again, so we need to work on its visualization. But this is the file that we will be using the next time for starting the classification using the machine learning algorithm. So please don't remove it. Don't remove, as you saw before, how it is possible to remove the file, but maintain it because we need it also in the next lesson. And probably this point is also good. I suggest you, Gorica, when you show them how to do, to save this project in such a way that they have all the data that are available by now in the project. Okay. Let's do the last point, that is the visualization of this file, and then I will give the word to Gorica. We want to visualize it. Wonderful. So we select the clip file and we click with the mouse, right click with the mouse. We have the second menu, which is properties. And with respect to the properties, what we want to change is the symbology. I don't spend many words here because we already know some of these passages. At this point, what we want, because this is an image, so we want to use as a typology for rendering the multi-band color. Okay, so now we have to say which is the red band. And if we go back to the previous slide, we see that the red band is this band, is the band 3. The green is band 2, and the blue is band 1. So wonderful. Let's put here that the red band is band 3, green band is band 2, blue band is band 1. And then at this point, just a bit of cosmesis in order to better visualize. We select the contrast enhancement, putting stretch to min max. And then we also select the 2% and 98% here as a cumulative, avoiding the first 2% and the last 2% of the value. So we're stretching them. Once we have selected all these parameters, we can select OK, and then we run the command, and this is what we see now. So now we are able to see the village in the desert, and this is the true visualization, the true color visualization of our image. Okay, now Gorica, up to you.
Okay. So first we have to create band set, and then we will also reach the point when we will show it in true colors or RGB. So band set, again, we are going to SCP menu, and it's the first option, band set. So SCP menu, band set. So here it's just now enough to refresh with this use refresh button to make all the bands that are available in the layers panel also available for creating band set. And then after having them all loaded in the SCP plugin, we have to select them all with this button here, and then add them all in the band set creation. After this, we have to order these bands so that, so after band set, these all bands that are now separate files will become one file altogether, like they will be organized in one file. So this organization or their order in this final file that we will obtain is arranged either with wavelength quick settings or with these buttons here. So in general, they should be ordered all in the proper way except for band 8A. So the band 8A should come after band 8 here. But the easiest way, I believe, for arranging bands is simply to select wavelength quick settings and then go to Sentinel 2 bands. And you will see that immediately after selecting Sentinel 2 bands here, we will have the order 2, 3, 4, 5, 6, 7, 8, 8A, 11, and 12. And the last point that we have to do before running this command is select create virtual raster of bands. And now this really you have to run. We didn't provide this, so you really have to run this command. And also I will run it, so run. It should be quite fast. We select some folder where we want to save output. And in fact, I will create one folder that I will call output. So just to have everything organized. And I created this folder, select folder, click on select folder. And you should also hear this sound when the command is finished. And okay, I will close this now to verify if I have this virtual raster actually. I expanded a bit just to be able to see the full name of all the layers here. And you can see that I have this virtual raster here. I will put it at the top so that it's the first one that we display here. And you see this, I will not go again into the properties of this, but now this is raster with 10 bands. So one raster, but it has 10 bands included. The next point for this raster is to clip it to this red rectangle that we have here. And then we will save it in our local memory, because right now we have virtual raster and this is just group of paths to different bands. But to create a proper local file raster, we need to add some more operations, and one of them can be clipping. So to clip this raster, we go to raster menu. Raster menu, extraction, and then clip raster by extent. So raster menu, extraction, clip raster by extent. And here, of course, first we have to select which raster we want to clip. and that is the virtual raster, so the one that finishes with virt underscore rast. Then we have to say the extent. So what are the coordinates in which we want to keep the raster, and everything that is around will be gone. So for this, we will we will click this 3 dots button next to the clipping extent to see what are the possible options. How can we select this clipping extent? And one of them is to use layer extent. And this is for us the most convenient because we already have working area file. So we just use that file to define extent to which we want also to clip the raster. So let's select this use layer extent. And use extent from, we find working area here. So we just click on this arrow and we select working area. We confirm, okay. And you should have coordinates inserted after confirmation here. Then we need to just define where we will save this file. I have to scroll, actually it's better if I just increase the window size. So now the last thing for this that we have to specify is where are we going to save this file. We can save it also as a temporary file, but since we are going to need it for the next session, we are going to save it properly in the local memory. So next to the clipped extent, this field here, we again select the 3 dots button. We go save to file. This means that we are saving in the local memory. And we find the folder where to save it. I will again save it in my output folder. And let us call it clip.tif because I will refer in the next session, we will use it and I will refer to it as clip.tif. So let us have the same name, clip.tif. In fact, actually, TIFF, the extension will be given by default, so it's enough just to put clip and that's it. Clip, save, and we can run now. And in a couple of seconds, we should obtain our result. I will close this clip raster by extent window now. And I have my clipped image now on the working area. So you see, I can actually hide all the other layers and display only this one now, because this is the only area that is relevant for us from now on. And okay, the last thing is to display this clip now as in true colors or as RGB image. To do this, we are going to properties of this layer. So we right click on clip layer in the layers panel, right click, properties. And visualization is of course changed on the symbology tab. We need to follow the order of the to follow the order of the bands. So red band is in case of our image band number 3. Green band is band number 2. So we keep the, oh sorry, I forgot to say that render type must be multi-band color. So this is very important, otherwise you will not see all the options that I see here. So render type multi-band color. Then for the red band, we click and select band 3. For the green band, we select band 2. And for the blue band, we select band 1. Then we use contrast, enhancement, stretch, min, max, this one. And we can expand min, max value settings to select cumulative count cut that is already selected by default. So with this, we can apply this style and see if we got our true color image. So I click on OK. And this is the result. And I hope that now you can see, if I tell you that this is some village in a desert area, I hope that now you can also see it for yourself, that here we have some buildings and here we have some sand, which is actually the desert. And yes, it's true colors. So I think that's it, Professor.
Yes, thank you, Goritza. So we are almost at the end, because we have everything that we need for the next lesson. But I want just to show you that we provided something more for you in the slides in such a way that then, if you are interested, you can try by yourself. And specifically, what you can see in the slides. So the slides are richer. There is something more that we can do. We are not able of doing now because it requests other time, but as a matter of fact, there is in the slides also the description about what we can do by using the band algebra. When you are dealing with satellite imagery, and it is very common to create some index, like for instance, one possibility is this normalized difference vegetation index. That is nothing but some algebraic analysis that is done on the band that we have. So starting from the data that we have now, the band that we have now, you can play with them in order to obtain different indexes. And this is one possibility. This is one possible index that we can consider. So in the next slide, you will find all the pieces of information and the instructions in order to compute this index. It is just an example of index because there are many examples, but for instance, in this case, this example is very useful if you want to detect vegetation. And in the slides, it is described everything, how it is possible to compute it in a very detailed way, as we showed in the previous slide for the previous processes of the data. And once you obtain this new file as a result of this procedure, you will be able to see where there is the vegetation and also a sort of typology of the vegetation, because depending on the value of this index, you can say that it is probably shrub or grassland, or it is probably forest. So in the next slide, you will see how to compute it. And then the very last part is how it is possible also to give to this new layer that you created a beautiful color. So, but I think that there is no time. And besides the time, I believe that what we were telling you before was enough probably for today, because it was a lot, and it was everything that was needed for the introducing the next lesson about the machine learning algorithm. So I want to ask also the other people participating to this workshop, so the Juan Pablo, Matilde, and Thomas, and Musa, and Francesco, if they want to switch on again their video in such a way that all together we can say hello to everyone. And thank you, Juan Pablo. Thank you, Matilde. And yes, thank you, Francesco, Thomas. Thank you. Thank you again. And above all, thank you, Goritza. And again, I believe that now we can give back the word to Andrea, probably.
I thank you very much, Maria and Goritza, for this very interesting workshop. And thanks also to all the students from the Politecnico di Milano, which assisted the participants in the QA and in the chat. We just put a poll. If you can reply, it will be very much appreciated. Did you manage to create the clip TIFF file that was at the end of the workshop? A big thanks also to all the participants for having attended this event in such a large number. I would like also to, we have also another poll. How likely you are you to recommend this webinar to a friend or a colleague? It will help us. I would like also to remind you again that the second and final session of this workshop will take place on May 11th at 1400 Geneva time. We are pasting the links in the chat and encourage you to join. We also encourage you to check out the i4Good program online to see more sessions that may be of interest to you. For example, on April 29th, we have the next trustworthy AI session that will discuss adversarial attacks and defenses. With that, we have reached the end of this webinar, and we would like once again to thank everyone involved, our speakers, our participants, our partners, sponsors, and co-convener Switzerland. Thank you very much, and hope to see you again soon.
Bye-bye. Thank you.
Thank you. Bye.
Selector, rewind selector, rewind selector, rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector, rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector, rewind selector, rewind Rewind selector. 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 Rewind selector.